Okay, so let's start with the second part. I'm closing some pictures from the previous. So from the previous, the first part of the lecture, we derived the linear model, which approximates at least the linear time invariant model and the recursive time varying model for the approximation of the output. And again, as already mentioned, this model will be exploited in the phase of the model predictive control with the disturbance compensation. So we already have this part. So let's move to the derivation or to the estimation of a nonlinear model. The model can be described as a neural network or fuzzy system. Is up to you. The best one normally is the process that you are using for the controller, later for the controller design. So I'm just keeping some details. So starting from the basic file, which is just to summarize you, the general model is a pressure model, and then I provided you a new file which is called pressure model data gen. So I'm just explaining the data gen 01 is the preparation of the data for as is written here as for the estimation of a static model. So it's a static model pressure vector that we already know. So I don't want to, it's up to you. If you want to try it, you remember you generate the simulated pattern, the simulated target, and then you perform the estimation of a static neural network. We already know that the results of this network are very limited. I can open you just the result. We have the results for just to the pressure model is validation. So I'm skipping some details, and then we move to the. We see here, for example, this is already trained network. Normally, you should start because you don't know how many regressors you need. So normally, you start with a network like this. So is the model validation of the neural network. Is just if you check, you can see here that for example, the error is as you can see is quite the performances are quite limited. You see here that in yellow you have the measured output, and in blue is the predicted output. The simulated output is the results are really not so good. So it means that you can neglect a static network, and what we are really interested in is the derivation of a dynamic network. So it's why I can just open I can show you, so I show you the result, and then the validation of here, pressure model validation of the neural network. And this is the result we obtained. So I'm going to show you the results. So you have this network is connected with the input, the output, and the performances of this network. So we can try to estimate this model. So starting from, for example, this, or I can open the file that you have already provided. So as you remember, for any regressor, you need to generate a new file. So this is the regressor. So let's start from this one. This is the file that is used for the generation of the regressors for the estimation of a dynamic neural network. So just we can try to quickly to estimate. So we have tsim and tsim. You remember, please don't modify. So I can, well, it's in Italian, but it's